Example 5. Use substitution to find the indefinite integral of 5x to the 4th e to the 7x to the 5th dx. Now think about when you take the derivative of an e to the f of x function. Remember, this is going to require the chain rule. It's going to be e to the f of x, and then we chain on or times the derivative of the exponent. So we're going to need substitution to do a function like this. Typically, when you have an e, the exponent is going to be your u, because that was the thing that we chained on. Remember, the derivative of that exponent was the part that we used the chain rule for. So I'm going to select u to be 7x to the 5th. And if I get this right, I can rewrite my entire integral expression all in terms of u, and I'll have no x's, and it'll be a lot easier to integrate. So we start by taking the derivative of this u expression with respect to x, because it's got an x in it. It's going to be 35x to the 4th. But what I'm looking for really, now we know what to put in for this exponent. I want to find something to put in for dx, and I can solve this for dx. So I'm going to multiply both sides of the equation by dx, and that's going to leave me du is 35x to the 4th dx. And remember, I want to get an expression just for dx, so I'm going to divide by 35x to the 4th on both sides. That isolates the dx on the right, and I can substitute in for that du over 35x to the 4th. So let's start to do our substitution. So we're going to get, well, I don't have anything for 5x to the 4th. And don't be worried about that. Sometimes you'll have an x expression in the first pass, and then once you get everything in there, it's going to reduce out. This is going to be times e to the u, all right, because our u was our exponent. And then for dx, I'm going to put du over, and look, this whole thing is going to eventually be over it, 35x to the 4th. These both are over 1s, so the du is level with the top of the fraction, and the 35x to the 5th is the bottom of the fraction. So I can do some reducing, just regular fraction reducing. I have a 5. It will divide into my 35 and leave a 7. I have an x to the 4th, which will divide into my x to the 4th and leave a 1. So all that I have left is going to just have u's. I've got an e to the u du, and that's over 7. Now remember, this is the coefficient 1/7, so I'll just put the 1/7 here. And then when I take the integral of e to the u, it's very easy, it's just e to the u plus c. So 1/7 e to the u plus c. Well, the last thing is, remember, we were trying to take an integral with respect to x, so we have to have this in terms of x. So that's going to be e to the 7x to the 5th plus c. Now, you can always take the derivative of this to make sure you got it right. It's not required. It's good every now and then to just give it a chance. And look, if I take the derivative of that plus c, it's going to be a 0, so I really don't have to worry about that, but I'll go ahead and write it. So the derivative of an exponential expression is 1/7. You copy e just as it is. You multiply that times the derivative of that, which would be 35x to the 4th, and then plus 0. And then, look, you have a 7 on bottom and a 35 on top, so that 7 is going to go into that 35, and it's going to leave me of e to the 7x to the 5th times, that 7 goes into there 5 times, so 5x to the 4th. And then if I rewrite that, 5x to the 4th in the front, e to the 7x to the 5th, you'll notice that's exactly what our problem was. So it's not a bad idea to take the derivative of what you get just to show that you have the right answer. But it's not required, okay? This is the check. It's not required.